Hi everyone. In this video, I'm going to explain a bit about how to analyze the results of scientific research. And in particular, I'm going to focus on correlations, which are frequently used to express the relationship between different variables. The first thing to know about a correlation is that it's expressed as a number ranging from -1 to +1. When we look at a correlation, we need to know two things. The first is its strength, which is determined by how far away from zero it is. A correlation of 0 means no correlation. So this might be, say, the correlation between your intelligence and the length of your pinky toenail. There's just no relationship. The farther you get in either direction, the stronger it is. So -0.8 is going to be a lot stronger than, say, +0.2. So that tells us how strong the relationship is. The other thing to know is the sign, whether the correlation is positive or negative, because this tells us the direction of the relationship between one variable and another. For example, here is some data from a public health study looking at over 300 American cities. The researchers created what they call a Metro Health Index, which is based on the percentage of people in each area who smoke or who are obese. And we can see here that there's a positive correlation between income and the Metro Health Index, meaning cities with higher median incomes are generally healthier. What's important to keep in mind here is that positive and negative are just math terms. This has nothing to do with good and bad, it's all just about math. So this is a positive correlation because the values tend to change in the same direction. Higher income is generally associated with higher or better health. On this next scatter plot, we see an example of a negative correlation. This means that as values of one variable increase, the other tends to go down. In this case, more people driving alone to work is associated with worse health. Another example of a negative correlation would be the relationship between absenteeism and grades, because people who miss more classes tend to get lower scores on exams. What's important to keep in mind about correlations is that they describe relationships among variables, but they don't necessarily tell us why those relationships exist. There might be a cause and effect relationship, but not always. And in fact, whenever we have two variables, we actually have three possibilities. Take the data we're looking at here, showing that cities with more people driving solo to work tend to have higher rates of smoking and obesity. One possibility is that A causes B. In this case, meaning that driving alone to work causes poor health. That doesn't really seem very likely. Same goes for our next possibility, which is that poor health somehow makes people drive by themselves. In this particular example, what's much more likely is that there are a number of third variables affecting the relationship between A and B. For example, maybe people who drive alone feel more lonely, and this makes them more likely to stress eat. Or in areas where people take more public transit, they have to walk to the bus or train, which means they get more exercise. One last possibility when we see a correlation between two sets of data is that there's always the chance it could be a total coincidence. For example, here's a chart showing that over 9 years, there was a very strong correlation between the divorce rate in Maine and American per capita consumption of margarine. There is absolutely no reason for this, except that if you look at enough data sets, you'll eventually come across a correlation purely by coincidence. Here's another, for example, showing a relationship between Nicolas Cage's acting career and American deaths by drowning in pools. Again, sheer coincidence. Finally, one last thing to consider is that whenever people think there's a correlation between two variables, they need to stop and see if there really is a correlation or if they are just imagining it. For example, people sometimes wonder whether dreams predict the future, right? That might be because of that one time they dreamed about someone who later died. But here's the thing. Most of the time, on any given day, You're not going to dream about Aunt Mildred, and she's not going to die, but nobody notices this. And if they dream about her and she doesn't die, they might think, that's interesting. But they're not going to be thinking, whoa, what are the odds I dream about someone and they're still alive? This is not going to be a thing. If she dies and they didn't dream about it, then they will be sad. But again, nobody's going to be shocked. But on that rare occasion where someone dreams about Aunt Mildred and she dies, now this is going to get their attention. So they're going to really think that there is a stronger correlation between dreams and death than there really was. So that's it for correlations. I hope you all have a wonderful day.